Here's a problem where we have to add two polynomials together. Right. A quick note about addition is that it doesn't matter what order we add things together in. We could do these terms in any order. We're still going to get 6 when we add them all together. So in addition, our order doesn't matter. So what we can actually do in this problem is get rid of those parentheses. We're not worried about them because the only operation happening here is this addition. And then to deal with the subtractions that are happening, like here and here, we're going to think of those as negatives, where the negatives are stuck to the number right after. All right. And what we're looking for are like terms that we can combine. So like terms will have the same variable and exponent. So here we have 2x squared. So I'm looking for other terms that have an x squared, and I see one right here. So I have 2x squareds, and I'm adding 5x squareds, that for a total of 7x squareds. Okay. Here, I have a positive 3xy. I'm taking that sign in front of it with it. And then I have a minus 3xy. These are like terms because they have the same variables to the same powers, an x and a y. And we have positive 3 of them, and then we're taking 3 of them away is going to leave us with 0 xy's. We actually don't really need to bother to write that term because that just will simplify to 0. Now, a positive 2w and a negative 8w. So 2w's, I'm taking 8 of them away. That will leave me with negative 6w. So our final answer here is going to be 7x squared minus 6w. Okay, in this problem, we're subtracting. Order does matter when we're subtracting. Think about 5 minus 3 is not the same thing as 3 minus 5. In subtraction, it matters what comes first. So I can't just get rid of these parentheses here. What I'm going to do is I'm going to turn this problem into an addition problem by distributing the negative to every term inside the second set of parentheses. And when I do that, I think about putting in a plus right here, and that negative will have been distributed to the term. So I'm just going to rewrite this whole thing. So I have 2x squared is 3xy plus 2w. Distributing the negative to a negative 3xy will make that into a positive 3xy. A negative times a negative for the second distribution is going to become a positive, so a positive 8w. And then negative times positive 5x squared will become a negative 5x squared. Now, this is all addition, so it doesn't matter what order I group things in, so I can group like terms together. Get a different color. All right. We have a 2x squared. We have a negative 5x squared. Those will combine to be a negative 3 squared. We have a positive 3xy and a positive 3xy for a total of 6xy's. And then we have positive 2w and a positive 8w for a total of 10 w's. So actually that is our final answer. Let me talk you through another approach to this problem. So we can think about doing, okay, without having to do so much writing, 2x squared, the term that I can combine those is I'm going to look over here and see, are there any other x squareds? And I see a 5x squared. And I have to remember I'm subtracting. So I'm going to have a 2x squared minus 5x squared. Then I have a plus 3xy and a minus 3xy. It's going to give me plus 3xy minus negative 3xy. Then I have a plus 2w. I'm subtracting a negative 8w, so plus 2w minus negative 8w. Alright. Anytime I have a negative that I'm subtracting, that cancels and becomes a plus. So now I'm going to do the step of combining like terms. 2x squared minus 5x is negative 3x squared. Plus 3xy plus 3xy gives a total of 6xy's. And 2w plus 8w becomes 10w. So you'll notice what I had written down is really the same thing we got with the last approach. We just thought about it a little bit differently, and you can pick whatever method you prefer. Here we have a multiplication problem, and in this case we have a monomial with one term multiplying trinomial, polynomial with two terms. So in this situation, what we can think about is it's a lot like distribution, where this monomial is going to multiply everything inside the parentheses. So there's going to be 3 multiplications to do. Okay. Up first, we have 2x times 4x squared. Numbers will multiply together just like they always have. 2 times 4 will give us an 8. And when we multiply variables together, I'll write this up here, x times x squared. The rule is that if they have the same variable, the exponents add together. If there is no exponent, you can think of there being an invisible 1. So this is going to become x to the 1 plus 2, which is x to the 3rd. So here we have 8x to the 3rd. Then we have 2x times negative 6y. We're making sure we take that sign in front of a term with the term. So 2 times negative 6 is negative 12. Then we have x times y. I can't use any rule like I used when I was multiplying just x's together because the variables are different. So the best I can do is to say x times y is exactly that. It's x, y. And then I have 2x times a positive 3. So 2 times 3 becomes positive 6. There's nothing for me to multiply the x with, so it just tags along 6x. And that is the final answer. Okay, here we have another multiplication problem where we have a binomial multiplying another binomial. So what we do is we're going to take every term in the first set of parentheses and multiply it to every term in the second set of parentheses. So this 2x squared is going to multiply the 4x, and it's going to multiply the negative 5's. Then this negative 3 it's going to multiply the 4x, and it's going to also multiply the negative 5. So there's 4 multiplications to do. Okay, so 2x squared times 4x, the 2 times the 4 will give us an 8. X squared times x is x to the 3rd. Then 2x squared, I'm thinking of this as minus 5, a negative 5. So 2 times negative 5 is negative 10. There's nothing for me to multiply that x squared with, so it just tags along. Now, taking this as a negative 3 to distribute to the terms in the second parenthesis, I get negative 3 times 4x is negative 12x. Negative 3 times negative 5 is a positive 15. Now I pause here and I check, are there any like terms? Sometimes you'll have like terms, sometimes you won't. Here there are no like terms. I have an x to the 3rd, which is not like an x squared, which is not like an x, which is not like a constant. So actually this right here is my final answer. Okay, on this problem we're factoring by greatest common factor, GCF. So the first step is to figure out what is the greatest common factor, and we look at kind of each part individually. So 8, 4, and 2, we're going to look at those coefficients first. So 8, 4, and 2, I'm thinking what number divides evenly into 8, 4, and 2? Well, 2 goes into all of those numbers. There's nothing bigger than 2 that will divide into 2, so that must be the greatest common factor. Next, I need to look at the x to the 3rd, the x squared, and the x. It might help a little bit if I write this out. X to the 3rd is x times x times x. X squared is x times x, and x is just x. So I'm looking for common factors. Well, there's at least one x in all of them. So the greatest common factor is x. It's always going to turn out that when you have the same variable in each term, the greatest common factor will be that variable to the lowest exponent. Our lowest exponent right here is that x. You can think of there being an invisible x to the 1st, so that's the greatest common factor. If we had something like x to the 9th, x to the 11th, and x to the 2nd, greatest common factor would be x to the lowest power, which is x squared. Let's get this out of our way. So our greatest common factor for this polynomial we get by combining these two things. So the greatest common factor is 2x. Now we're going to divide every term by 2x. Set up this division. And then I'm going to look at the numbers and the variable parts separately. So for this first term, 8 divided by 2 is 4. And I have x to the 3rd divided by x. Well, that's x times x times x divided by x. You'll notice an x on the top and bottom. Anything divided by itself is 1, so those cancel, leaving me x times x, or x squared. So the rule when we're dividing variables to powers is that the powers will subtract. There's one x on the bottom here. You think of that as x to the 1st, so it's going to cancel one of the 3 x's up top, leaving with 2 x's. Right, next term. 4 divided by 2 is 2. X squared divided by x. Think of this as x to the 1st. The powers subtract. This one x cancels one of those 2 x's. leaving with just an x. And then plus 2x divided by 2x is just the same thing on the top and the bottom, so that simplifies to a 1. Now careful, this is not our final answer. What we need is to include that greatest common factor, 2x. So we put what we get after we did the division in parentheses with the greatest common factor out front. If we did multiplication at this point, and I distributed that 2x back to every term, that would take us right back to where we started. So that's a way you can check that you did your work correctly. So factoring and multiplying are kind of their two opposite operations. They cancel each other out. So what we've done is we've factored out the greatest common factor. If we multiply it back in, we'd get right back to where we started. Here we have another problem where we need to factor by greatest common factor. So we're going to look at the coefficients first. 3, a little better, 3, 5, and 10. Well, let's start with the 3. The only factors of 3 are 1 and 3. 3 doesn't go into 5 and 10, so the greatest common factor here is a 1. Now we're going to look at the variable parts. We have an x squared y squared, an xy to the 4th, and a y to the 7th. Okay. The greatest common factor is not going to have an x in it because only the first and second terms have an x. The third one doesn't have any x, so we can't have an x in our greatest common factor. All the terms do have y's, so we'll pick y to the smallest exponent. So here we have 2 y's being multiplied together. Here we have, there's 2, here we have 4, and here we have 7. So each term has at least 2 y's being multiplied together. So our greatest common factor is 1y squared. I'm not going to bother to keep writing that 1. Multiplying by 1 doesn't change anything, so we're just going to call it a y squared. So we're going to divide every term by y squared. We're going to end up with a y squared out front of what we have left after dividing inside the parentheses. So 3x squared, there's nothing to divide that with, so that sticks around. Y squared over y squared, that cancels out and becomes a 1. Okay. Then we have plus, well, 5 divided by, there's no number down here to divide, so that's a 5. X isn't being divided by anything, so we still have an x. Y squared divided by y to the 4th. Just to write this out again, so that's y times y times y times y, that's y to the 4th, over y times y. So 2 y's cancel top and bottom, leaving us with 2 y's multiplied together, so that's y squared. Using our shortcut, I can think y to the 4th divided by y squared is y to the 4th minus the 2nd, which is 2. 4 minus 2 is 2. And then for our last term, I'll use that shortcut again. Negative 10 isn't being divided by anything. Y to the 7th divided by y squared is going to be y to the 5th. I think these 2 y's cancel with 2 of the 7 up here, leaving us with 5. And that's our final answer.